Section 3.5 is going to be our last section here in Chapter 3. And we're going to learn about a couple new probability rules and, more importantly, a new organizational tool to help us try to display probability information to help easily answer some questions. Let's take a look at example 1 to kind of get a sense, though, of what we're working with here. All right, suppose we have the following. In Neverland, suppose that men constitute 60% of the labor force, and the rates of unemployment are 6% and 4.5% among males and females respectively. So 6% for males and 4.5% for females. Suppose that a person is going to be selected at random from Neverland's labor force. Okay, now again, I've left some space here because I want to go ahead and start to fill in at least a little bit of some symbols that I can use here. So how about we go ahead and use the symbol M to stand for that the person is male. So then we can easily use F to stand for the person is female. We can go ahead and use U to maybe say that the person that we select is unemployed. And therefore we could probably use E as a good way to mark that the person that we've selected is employed. Okay, so I have these different values here, and what I'll notice is that I've also been given some percentages in the question, right? So I know immediately from the question that the probability of M, the probability that the person that I select is a man, well, that's 60%, because men constitute 60% of the workforce. Now, I also am told rates of unemployment, but I got to be careful here. I'm told that the unemployment, or the chances that someone is unemployed is 6% if they're a guy, 4.5% if they're a gal. So notice that these are actually conditional probabilities, right? Because I'm told that the chances that I find someone unemployed, given that I'm only looking at males, that is 6%. And the chances that someone is unemployed, given that they are female, well, that's 4.5%. So I have all these different numbers here. Okay, so let's take a look then at part A to try to see how we can answer this question. What is the probability that the person selected is ultimately going to be unemployed? Okay, well, I mean, let's see. So I want to find, let's write this down. We want to find the probability that the person is unemployed. But I don't have that information, and it's tough to think about how I could get it. Instead, I'm going to go ahead and attempt to compute two other things. Let's take a look. I'll say, how about we start by calculating the probability that I find someone who is a man and is unemployed. Notice that's different than what I have right here. But I can easily go ahead and compute this by using my multiplication law for probability. I would say, first I find the probability that the person is a man, and then I find the probability that the person is unemployed, given that they are a man. Okay, if I was to do this, notice I have those numbers. That should be 0.60 for the first probability times 0.06 for the second probability. And if I multiply those out, I should get 0.036. Okay, great. Now I'm going to calculate one other thing here. Probability that the person that I select is female and unemployed. By similar logic, this should be probability of F times probability of U given F. And even though I don't have probability of female written down, again, I should be able to easily see that if 60% of the labor force are male, then it should be that 40% of the labor force is women. So I'm going to have 40% times my 0.045 unemployment for females. And when I multiply that out, I get a value of 0.018. Now, why am I doing this? What was the goal in computing this? Because obviously neither of these two things is what I'm looking for. So why would I do this? This is the goal right now, trying to understand the motivation. Well, I think that once I have information with ands, and I have information with individual variables, I can say that we can now organize our information in a table So let's see what I mean by this. Like what would this table look like? We've seen lots of tables in some of the previous sections, but how would I use that here? Well, remember that when I go ahead and I create one of these tables, I'm going to have usually, let's see, I'll draw out a couple nice neat lines here. I'm going to have actually 3 different vertical lines, and then I'm going to end up with a bunch of different horizontal lines as well. Going to have 3 horizontal lines coming across here. Let me actually move that one up a bit so I can make a little bit more space. Put this one here, and I'll put this one here. Now the reason that I'm setting up my table is because I can think about organizing it in the following way. What if I put unemployed category up here next to employed, and then I could put male and female over here. Notice I could start to fill in this table, not with numbers of people in each group, but with the percentages. And I know that the grand total percentage that I'm working with is 100%, or 1.0. So take a look at how I can start to fill this in. What would be the total percentage of people that are male? Well, we have 60% in the labor force. Total percentage that are female is 40%. That makes 100% total. Well, notice I don't have unemployed or employed yet, but I do have these and values. So I know that males that are also unemployed are going to be constituting 3.6%. I can put that in the table. Same thing for females that are unemployed, 0.018. Notice I can now even start to add across and down, and I can get a whole bunch of other values in here. So this value here should be 0.564. Notice because when I add across, I get back to 0.60. This value in here should be 0.382. If I add down this column, I'm going to get 0.946. Ooh, and notice if I add down this column, I'll actually get the total percentage of people that are unemployed, and that ends up as 0.054. So here it is. This is the value that I'm looking for. So I can go ahead and then say that, I'll say, so the probability of U is equal to 0.054. We got it. That's easy to see. Notice that I actually was able to find that value by taking the men that were unemployed, the women that were unemployed, and kind of just adding those results together. And the way I was able to then organize this data with the table was really great as long as I actually had these pieces of information that were given in AND form. Notice that there was nowhere in this table to put these conditional probabilities. These percentages didn't show up anywhere in here. They don't fit inside of a table like this. A table only has room for ANDs and grand totals. But what's interesting here is that what we've really seen in this question is an important new law of probability, what we call the law of total probability. Now, oftentimes we will never really use this law directly, as in we'll never write down the formula. We'll often think about it in this table representation or in a new representation we'll talk about in the next video. But here you'll see that we found the probability of an event by taking a look at the probability of all the people in, say, Group B and not in Group B that were also in that event. Kind of like here, we looked at males and females who were all unemployed. We looked at all of the unemployed individuals and kind of added up their individual percentages. What's kind of weird is that you can actually take these probabilities with ANDs and you can rewrite them using the multiplication law that we talked about a couple sections ago. And so you can make this formula look really horrific, even though when I look at the table, it seems pretty simple. We'll see, however, in the next video why we might actually care about these particular representations and why it's helpful to think about finding this probability of A, not just by using ANDs like we did here, but also with using conditional probabilities like what we started our question with. We'll see a different way in the next video that we can organize our data to help with this.